exponential function you just did. Okay? So logarithm is just an exponent. If we go log base b of x, that equals y. So if I write that in exponential form without the log in there, this is what that says. Okay, this is the same as b to the exponent of y is x, and that's something we're familiar with. Okay, so it's just written differently. Like this thing is the exponent, right? My exponent here is y. That's what a logarithm is. It's the exponent. So it's saying the exponent on which we put on a base b is equal to x. That's what it says. The exponent on b to get x. Okay? So we don't have to delve too much in this, and then you say, well, what's your base? So all we're going to say is we're going to use base b is going to be 10. And when you hit that log button on the calculator, that's the only base it does. Okay? It doesn't have base 2 or base 5 or base something else. When you hit log button, it understands b's 10. Okay? So that's the only one we're going to use. Actually, I lied. We're going to use e, which is ln. You see the other button on there near it called ln? That's called a natural logarithm, and it uses that funny letter e, which stands for lots of cool stuff in nature. Okay? Euler's number. So, just as a little example, and we don't get into the algebra too much, but what is that? Just looking at this example here, can someone kind of puzzle this thing out? 10, that says log base 10 of 100 is, what's the answer? Well, where does the 10 go? Where does the 100 go? Where does the exponent go? What are we trying to solve for here? I'm trying to solve for y. So make two substitutions. What's the answer? $10 to what is equal to x is 100. What's the answer? 10 to what power is 100? What's 10 times 10? That's it. Right? What is log? And you don't have a base button here. It understands it's base 10. What's log of 100? It's 2. It's saying what is the exponent you apply to 10 to give you 100? It's 2. Okay? So that's basically as far algebraically as we're going to go. Okay? We want to, in this course, analyze the graph. So a can be just some number, some constant in front of log, and b is basically going to be 10 of x. Let's graph this thing and see what happens. Okay? Come on. Okay, so b's 10. Okay? Well, what does a do? That's this funny number in front. So example. Let's let a be 2. I just want to graph that. 2 log x. What happens? Oh, by the way, you got to remove scatter plot. Okay, if you got plot on, you got to get rid of it. So go second function from yesterday. Stat plots, make sure they're off now. Stat plot off. You'll know because there it'll be in black. It'll be highlighted in black. So if you see that, you got to kind of get rid of it. 2 log x. Funky little curve.
Where is the window at?
Well, that's my next point. What do I want my window settings to be? I can't really see what's going around the origin there, is there? Do you see any negative x values here? There aren't any. And guess what happens right here at the curve, just below the origin? Well, we want to start x at 0. Let's put it that way. 2 log x. Okay? So there was no negative x's, so let's just start it at 0. How do I blow that up a bit more so I can see what's going on? Let's not make x as long here. Let's just go to I want to make this 1. I want to see it a lot bigger. So let's go just to 3. And then there doesn't seem to be much happening under y is -3. So let's just go from I don't know, 4 to 4 for y, let's say. So from -4 to +4. And well, it's about as good as it's going to get, I think. Okay, that's 2 log x. Let's graph it. Okay, that's 1, 2, 3. Okay, it looks like it about 1, 2, 3 for y down there. And then where does it go through here? What is my x-intercept? There's 2. What's that? Is that 1? It is. I'll tell you, it is. Okay, and then put an arrowhead on it. Goes forever and ever and ever. Okay, so that's 2 log x. How about 5 log x on the same graph? Okay, I got colors, so I'm going to use a different color. What's the 5 going to do? Good call. Does the x-intercept look like it's the same? Sure does. Goes through the same point. So it's a little farther from the y-axis down on the bottom, and it goes up a little higher. Still goes through 1. Okay, so that's the top one. Now let's put something else on here. This is called a natural logarithm. It's log base e. If I use a base of this funny e number, which by the way is like 2.71 something something something, it means cool stuff in nature. Okay, I'm not going to get into the details, but that's just ln x. If you see that, just go and hit the ln button, and then x, just like log. It is a log. It's a natural logarithm. And then where's that guy? That looks really, really close to 5 log x, doesn't it? Okay, so that's pretty similar. I'll use green here. Yep. Sorry? Okay, that's what A does here. A is 2, here A is 5. A is both what? Positive. Okay, something different happens if it's negative. Let's have a look. Any guesses? Same window. Let's just put -2 log base 10 x and see what happens. You got to use that little minus on the bottom, remember? Whoop. I want 2 of them. Flipped over the x-axis, right? Okay, let's get rid of those guys. Yeah, what stupid commercials is that from? So, it just got a mirror image over the x-axis. Okay, what was my x-intercept here? It's still 1. I'll tell you why in a sec. Okay, so do I need to do any more? What if I do a -5? Exactly same shape, just invert it, right? Okay, so that's what A does if A is less than 0, i.e. negative. Okay, so remember some terminology we had for exponential functions? Would I call this one increasing or decreasing if A is positive? As x gets bigger, what happens to y? It gets bigger. Okay, that's increasing. This guy is decreasing. Do we need to talk about what quadrants these both go in? Well, that's 1, that's 4. If it's decreasing, it goes from 1 to 4, and opposite if it's positive, right? From 4 to 1. Same questions we got before. What's the domain? What's the range? What? What? Are you serious or are you kidding? What are my x values for this graph? What's the domain? Well, it's definitely above this point. Does it go that way forever? Yes. How far this way does it go? Well, we haven't really talked about this. You know what's happening down here? That's an asymptote. So everything just greater than 0. Okay, not equal to 0. It never can be 0. And algebraically, we can analyze that. The range, what can we say about the range? I just told you it goes down forever. And does it go up forever? All real. By the way, to be picky, let's put x as all real as well, right? Greater than 0, all real. Does that change if A is negative? No, it doesn't. That's right. X greater than 0, same thing, okay? For that and for this one. Okay? What else? I talked about it, but we didn't write it down. What's the x-intercept? Well, let's go back to the equation. Let's look at the logarithm. What happens at the x-intercept? What's the value of y at the x-intercept? That's right, everybody. Y is 0. At the x-intercept, well, look, right? Y is 0. Well, what is anything to the 0 power? It's 1. Okay, that's why it's 1. Where y is 0 as an exponent, okay, 10 to the 0, it's 1. Okay, so where y is 0, I don't care what b is, x is going to be 1. Okay, always, always, always. So that shouldn't be a big surprise. Domain, range, x-intercept. What's the y-intercept? Well, if the y-axis is an asymptote, where is it going to cross it? Trick question. It doesn't, yes. Okay, so the x-intercept is 1 always, no y-intercept. Okay, because it's an asymptote. Yes. Okay, that's about it. What is an asymptote?
A line that never
Gets closer and closer and closer and closer, but never touches it.